Welcome everyone to today's Edison Electric Institute webinar, CarbonFree Technologies, the Foundation of a Clean Energy Future. My name is Vanessa Ferrero and I'm a manager for international programs at EEI. Today's session launches EEI's Destination 2050 Dialogues, our COP26 webinar series that will highlight critical issues for the clean energy transition. We are excited to welcome two speakers today, David Carroll, Chief Renewables Officer for ENGIE North America, and Jason Comandante, Vice President of Commercial Services for Capital Power. They will be joined by Dr. Lawrence Jones, Vice President for International Programs at EEI. This session is a dialogue, so we encourage you to ask questions for our speakers using the chat feature. Lawrence will aim to incorporate as many of them as possible into the conversation. Without further ado, I will turn this over to Lawrence to get started.
Thank you, Vanessa. Good morning, everyone. Good afternoon, and also good evening, depending where you're joining us from. We're delighted this morning here from Washington, D.C. to be joined by Dave and Jason, representing ENGIE and Capital Power, respectively. As Vanessa said, this is the first in a series of webinars we're going to have as we kick off our Destination 2050 dialogues in regards to COP26. Obviously, the first webinar is being held exactly 1 week before the world heads to Glasgow to kick off the COP26 dialogues. Obviously, our power sector, the electricity sector, power sector more broadly, is going to be key part of the conversation in Glasgow. And so we thought, what a better way to start this series by focusing on the issue of what is going to be the kinds of technology, carbon-free technology, that will be the pillar for us going forward. So to begin with, I'm going to ask Dave and then Jason to first of all just tell us about your company, in which countries they operate, and just some of the things you guys do from the perspective of not just carbon technology, but more broadly as an organization. So let's start with Dave, and then we'll go to Jason. Dave, you go first.
All right, thank you, Lawrence. And again, I want to thank everyone for having me here today. It's an honor to be with you, and also to just speak about things that I personally, but also ENGIE as a company, is very passionate about, which is moving towards a carbon neutral economy. So as Lawrence mentioned, I'm the Chief Renewables Officer for ENGIE North America, responsible for all of our renewables installations, operations and maintenance, or ownership and operations of our renewables here in Canada and the US. ENGIE is about 170,000 employees based in Paris, France. As Lawrence mentioned, we are a multinational company operating in over 20 countries, obviously with numerous countries in Europe, a strong presence here in North America, as well as Latin America and Brazil, Peru, Chile, Australia, Egypt, South Africa, among many other countries. And our entire focus is on moving towards a carbon neutral economy. If you look, we provide services across the whole value chain. So I'm part of the renewables business, which is really in the power generation phase. Inside the renewables, we have some nuclear assets, but also primarily focused on wind, solar, hydro, geothermal, and biomass assets around the globe. And then we also have what we call our global energy management supply business, which is really power trading and provides retail electricity to our customers, allowing a broader group of our customers and clients access to renewable energy and energy management services. We also have an energy solutions group, which is really client focused. And it's a business that provides energy efficiency services, district heating and cooling, and distributed generation across all of our clients' needs. So this is where you have the business that has the public-private partnerships that we'll speak about, where we're providing services to colleges and universities such as Ohio State or Georgetown, as well as large corporate customers. We also have a networks business, which is installing, owning, and operating transmission lines, distribution lines, as well as gas pipelines throughout the world. And then finally, we have a thermal business, which has really been reducing and changing its focus, and is really now much more focused in the transition towards a hydrogen economy going forward. So really, in a nutshell, that's ENGIE. And our whole goal, as our global CEO, Catherine McGregor, mentions, is really to drive towards a carbon neutral economy and meet or exceed the global targets of getting to net zero by 2050.
Thank you, Dave. Jason, over to you.
Okay, thanks, Lawrence. And like Dave, I'll share my appreciation for the opportunity to speak here today. Good morning to everybody, or afternoon if anybody's in a totally different time zone. Starting with a bit of an overview on Capital Power, I think the tagline on our website would show that we're a growth-oriented North American wholesale power producer with a strategic focus on sustainable energy. So just going into a little bit more detail on that, in a few more words, effectively, we build, own, and operate utility scale generation facilities, and those facilities include renewables such as wind and solar, and thermal as well, such as natural gas and coal that we're transitioning off of. I'm assuming that we'll get into some more of that discussion a little bit later in a program here. Our current portfolio consists of about 6,500 megawatts of generation capacity, and that's across 28 facilities, all located in Canada and the US. And we've got another about 1,000 megawatts of generation capacity in advanced development. Our strategy embodies sustainability. Last year, we developed a roadmap to 2050, outlining our steps towards our goal of net carbon neutrality by 2050. And among other elements, that roadmap contains our current just over $3 billion of investment in renewables, as well as repowering and advancement of carbon capture, utilization, and storage. Again, get into that a little bit later. And also our early exploration of direct air capture to physically offset emissions from our portfolio. My particular area of expertise, as indicated by my title, is on a commercial services side of the business, specific just to Canada West. Myself and my counterpart have a geographical split between the commercial services groups. I've got the province of Alberta and BC. And in those two provinces, I'm responsible for commercial services, which is the optimization and transition of our existing assets, dealing with all of the commodity exposure that comes from those assets, whether it be power, natural gas, or environmental attributes, as well as having an origination presence where we look to serve our customers' needs, traditionally with provision of electricity, but also have announced this year a couple of renewables offtakes with corporates. That's been an exciting newer piece to our portfolio of business.
So thanks, Jason. So as I said, gentlemen, a week from today, the world leaders will gather in Glasgow to talk about solutions for dealing with climate change. In recent years, to be fair, our industry has been very active in terms of making significant reductions in greenhouse gas emissions, and so much so that almost a majority of them are now putting in place their goals for net zero goals, as well as emissions reduction. So can you talk a little bit about your respective organizations' net zero strategy or emissions reductions goals, and then maybe just give us an update on the progress since those goals were put in place. So maybe we'll start this time with Jason and go back to Dave. Talk about Capital Power strategy for net zero and emissions reductions and where you guys stand today.
Sure, thanks, Lawrence. So I think where I'll start focusing, and I alluded in my introduction there to the Genesee Power Station. So I think I'm going to focus my answer largely there. We're doing some things I would call, shorter term in nature, but very real as opposed to just aspirational. But those all, of course, help us march towards our goal of that net carbon neutrality by 2050. So if you'll indulge me here, I might get into a little bit of a longer answer, but I think this really helps set the stage for an example of what Capital Power has in its portfolio and what it's looking to do with what it has in its portfolio to advance our carbon emission reduction. So just to start, and not with too much history here, but Capital Power is headquartered in the city of Edmonton, which is in Alberta. And just about an hour's drive west from Edmonton, Alberta, is the Genesee Power Station. So right now, the way that Genesee is situated is it is a 3-unit combined 1,250 megawatt capacity coal-fired power station. It does have the ability to burn some natural gas, about 1/3 across the 3 units. And those 3 units, since as early as about the mid-'80s, have provided Alberta with reliable baseload power. Before I get into some of the things that we've been advancing just over the past 12 months, leading up to those past 12 months, we've really focused on what we've termed the Genesee Efficiency Program. And with that efficiency program, we've been able to decrease greenhouse gas emissions at the site by 12%. So again, from a coal-fired power plant perspective, the reduction of 12% is quite material in the grand scheme of emissions reductions. And in that context, we also joined the Global Powering Past Coal Alliance. So that maybe sets the stage for the Genesee facility. Like I said, that's just outside of the city of Edmonton. And well, it wasn't even a year ago today. It was late last year, late in 2020, we made a very material announcement towards decarbonization, and that was the Genesee Repowering Project. And so effectively, and in relatively plain English, what I'll say is that a repowering project is more than a simple conversion of a coal plant to a natural gas fired plant. What it effectively does is remove the boiler and replaces it with a gas turbine, leaves the existing steam turbine in place. And what the effect of that is, and what we're doing to just the first Genesee, first and second Genesee units, so just Genesee 1 and 2, as I mentioned, there are 3 there. On Genesee 1 and 2, that repowering project will reduce emissions by approximately 3.4 million tons per year, while adding approximately 560 total megawatts of capacity. In addition to that, Genesee 3, the third unit, which is the newer of the 3 units, that will also transition entirely off of coal and to gas operations only. This will all happen by the end of 2023, and that's 6 years ahead of Canadian requirements to be off of coal. Just to throw out another couple of data points there, for Genesee 1 and 2, that will effectively move, as we move from coal down to the repowered natural gas facility, will effectively drop our emissions our emissions intensity from approximately 1 ton per megawatt hour to 0.35 tons per megawatt hour. So that's where you get that sharp reduction in emissions intensity. I might stop there. The next phase, and this is what we're exploring, we've been talking about a little bit more publicly recently, is to go a step further and take Genesee 1 and 2 from a coal unit to a repowered natural gas unit to adding on CCUS for carbon capture to further reduce the emissions on that facility as well.
Well, that's great. We're going to come back to the CCUS piece that, Jason, I think is important. Dave, let's talk about ENGIE. What is in your strategy, and what are some of the timelines you guys have ahead of you?
Yeah, so we have a few different strategies, but the ultimate strategy is 2045 to be net zero. And that's net zero across scope 1, scope 2, and scope 3 emissions. And for those that are not aware, scope 1 are those emissions that are direct emissions from your owned assets, owned and operated assets. Scope 2 are those emissions they're indirect emissions from purchasing electricity, steam, heating and cooling associated with operating your assets. And then finally, scope 3 are indirect emissions that are caused by, that are inside the entire company's supply chain. So ones that are really very hard to get to. And so that's the toughest goal, and it's a very ambitious goal. It's 5 years ahead of where most global companies are going for. And there's a big focus from our CEO, Catherine McGregor, to get there. We've also launched, as part of that, a program called Ellipse, which is really to provide us and our customers a view of where our carbon intensity is coming from, because we really have to try to figure out where the carbon is coming from and then determine a strategy and a roadmap to eliminate or reduce that carbon in order to achieve that goal. So very ambitious. We also had about 30 gigawatts of renewable generating capacity at the end of 2020. Our goal is to get to 50 by the 2025 and then 80 by 2030. So this year we'll put about another 3 gigawatts, and we're accelerating in order to meet that 30 by 2025. In addition, as part of that, by 2025, in order to meet our net zero by 2045, we've committed to increase reduce the amount of carbon usage in our customer value chain from 20 million tons per year, which happened in 2020, to 45 million tons by 2045. So really working towards not only our own carbon intensity, but also that of our customers. And I really think, for this audience, I think a lot of that really is great, because a lot of that it gets down to the value chain. It's not just in the utility or the power generation facilities that we really need to reduce the carbon intensity. It's across the entire value chain. It's transportation, it's buildings, residences. And for utilities, particularly those in the electric utilities, or even natural gas, where you're switching to renewable natural gas or to hydrogen, that is a very large increase in customer base that you can look to address with a much more efficient renewable energy focus.
So given where we are, and this is great. So we got two dates. We got 2045 for ENGIE. We got 2050 for Capital Power. Both of you have started your journey to get where you need to go. But we know that technology is can get us, maybe 80% in most cases. We have the technology to get us there as a globe. But obviously, there's still some more R&D to be done and some other deployment and demonstrations. So there are a couple of technologies I want to get your thoughts on, whether you guys are working on it or you just have some perspectives on it. So the four big ones, obviously, and this might be for you, Dave, because you're advanced wind and solar, different ways to do it, long duration storage, hydrogen, CCS, and advanced nuclear. So those are five of the sort of carbon-free technologies that most people are talking about. You guys want to just talk about what you guys might be working on either of those, or just your own perspectives? Let's start with Dave.
Yeah, so we're obviously working on pretty much all of those at this moment. Big focus, just increasing efficiency on solar. It's land-based. That's going to be useful in many areas that don't have access to wind, Southeast US, many parts of Europe, as well as South America. But a lot of focus on offshore wind. And we really only opened up a little bit of the offshore wind because most of it is seafloor fixed. And we're starting to see RFPs coming out in regards to floating off of Japan. You're really going to need that. You're going to need it on the west coast of the US, areas where the continental shelf drops so quickly that you really cannot have fixed wind turbines out there. And these machines are getting larger. They have a higher capacity factor, and they really can operate a lot of our, big urban populations where you cannot have the access to that renewable energy as well. Long duration storage, I think that goes hand in hand as well with hydrogen, because it's really not just going to be battery storage, which everyone's focused on right now, but you have to have a form of long duration storage. And I think hydrogen, both blue and green, are going to play a pretty substantial role. We're really focused on the green hydrogen. We have one of our pilot projects is partnering with Scotech, which is a Norwegian renewable company, to provide green hydrogen to a mine in South Africa. That mine right now relies on diesel gensets in order to provide its power. We're working to transition that so that they're working on green hydrogen. There's a lot of work that needs to be done, and as in the past with wind and even solar, Europe is really leading the adoption of that. They are really pushing through regulatory framework and the adoption and the investment in green hydrogen technology. So it's something that we really need to work on. And most big changes like this to solve a massive problem is really governments working together in order to solve that problem, because it really takes a lot of public money to take those big risks and those R&D to push these types of programs forward. So really that's what we're seeing quite a bit of. And we're also looking, we've reduced our carbon fleet or our coal fleet from 15 gigawatts in 2015 down to about 4 gigawatts last year, and it'll be totally gone in 2027. But also looking at our natural gas. How do we turn what natural gas we have left? How do we make it not a base load, but more peakers, and then get the carbon capture technology on top of that? So a lot of investment in those as we're moving forward. And I think AI is going to play a huge role as we advance those that R&D efforts.
Jason, what about you? I know you were alluding to the whole CCUS, and that's one of the big areas where you guys have been playing. Talk a little bit about some of the technologies you guys are looking at, and I'm very keen on the CCUS piece.
Yeah, okay, so I'll break this into two. I know typically anyways, and maybe most of the audience thinks of CCUS as post-combustion capture when it comes to the electricity sector. But there's a utilization component that I'll touch on here as well, which is probably the most novel, maybe the most interesting, generates some questions potentially, but probably starts getting into those more advanced and more future technologies, although we're looking to advance it fairly quickly here. Just getting back to the post-combustion capture, continuing on with the Genesee story, our plans are to install post-combustion capture on the Genesee 1 and 2 power stations, and those are those two repowered from coal to natural gas facilities. So they're approximately 700 megawatts each. So with post-combustion capture, that would provide 1,400 megawatts of baseload reliable supply to the Alberta system. What we're looking at is utilizing, I'll call it, commercially available technology, as opposed to, I'd say, like a bleeding edge type of technology. We've definitely had a number of conversations with some advanced post combustion capture type of entities that are looking to take their either lab or demonstration scale technologies sort of into the commercial area. But at this stage, Capital Power's focus has been on those more, I'll say, larger name, commercially available post combustion capture techs. It's CCUS, pardon me. And for those who maybe aren't as familiar with some of the more recent goings on in Canada, has become a fairly major topic at both the provincial and a federal level. So recently, over the course of the summer, the provincial government, for example, has kickstarted a sequestration tenure rights competitive process where they're looking for entities to bid into a competitive process to be granted sequestration rights for storage of carbon in deep saline aquifers, which in and around Alberta and in many parts of Canada we're blessed with. So there's a whole host of storage opportunities. On the federal side, there's been announcements by the federal government, and we're waiting to see how both the provincial and the federal government's support mechanisms play out here. But the federal government has announced funding for CCUS. The exact form of that funding, how it's going to play out, is still under consultation. But to give a sense for how quickly things are moving, we expect, and as per announcements that's been made by the government, that both on the provincial and the federal side, we'll have some fairly reasonable clarity on the sequestration tenure rights for where carbon's going to go, and on the federal side, what type of funding and support mechanisms may be in place as early as the first quarter of next year. And so with that fairly accelerated timeline, Capital Power has been engaging in our feasibility, pre-feed, and feed study type of efforts to get a really good handle on what it's going to take to bring our carbon footprint that much further down at Genesee. At this stage, what we're seeing, I mentioned that we went from about an emissions intensity of about 1 ton per megawatt hour down to 0.35 tons per megawatt hour with the repowering efforts. With post-combustion capture, we'd look to capture 90+% of those remaining emissions, bring our emissions intensity down to, call it 0.03. So not exactly carbon free, but extremely low and very near carbon free, again, for a base load reliable type facility.
So, one of the things I've always been intrigued about, David and Jason, is the timeline for when these technologies will become commercially available. And you mentioned the word commercialization, Jason. From what you guys are seeing and you talk to technology providers, can you give us a thought on some of the timelines for when these things will be really scalable, whether it's the CCUS piece, but even the long duration storage? What timelines are we looking at? We're talking about 5 years, 10 years, David and then Jason.
So I think for green hydrogen, I think you're looking at less than 10 years really for it to be economical. By 2030 or less, I think you really start to see that, and we're always blown away about how fast things end up ultimately moving once you start to get some momentum behind them. So I really think that's going to be the case. I think you're going to see some efficiency gains as we move the battery systems. If you look at, there hasn't been a ton of battery research since the early 1900s or late 1800s, and that's really accelerated. And you're seeing the cost curve come down on batteries, and then we're also seeing now a shift from some of those materials, because some of those materials are coming from troubled areas of the world where there are labor abuses and just lower environmental standards, and we're seeing the industry start to shift away from that. As far as carbon sequestration, I kind of see it's there. I'm not sure that's the right answer. Obviously, it helps reduce the amount of carbon that you're utilizing. I think it's better to probably shift from those types of things, and we have to have a slow shift from natural gas. Obviously get rid of coal, and then you work down the chain to reduce the carbon intensity across the board. And one thing we didn't mention really is, how do we start to be more efficient in what we're using, and not necessarily always be adding as we're increasing our technologies that we're utilizing. How do we become more efficient with it, so we have to add less in order to gain the same amount or more of our energy usage? So I think that's something that we should be focused on, but I'll let Jason answer in terms of the others.
Okay, good. So before Jason answers, so basically for the audience, we got from David here, Dave, 5-10 year time window, we should be seeing green hydrogen become a reality on a scale, I guess that's going to have an impact. Jason, what about you? CCUS?
It's at scale now.
Okay.
There's facilities across the world. Just to the east of Alberta, in our adjacent province, Saskatchewan, there's the Boundary Dam facility that's employed post-combustion capture on a coal-fired power plant. And so as far as the scalability of the technology, it's available at scale now. One of the things, and maybe this is what David might allude to with respect to economic viability, is that's I think what's typically maybe held back some of these technologies, is that they're available, they can be deployed, but the whether it's the policy or the economic components need to come together as well. And that's what I think, we'd see the Canadian government doing, is seeing a technology that's commercially available, scalable, but it may need the support, whether that's from a policy perspective or from a straight funding perspective, to get it over the hump. Again, for folks that might not be as familiar with Canadian environmental policy, our government has announced a transition from a current $40 per ton carbon value to a $170 per ton carbon value by 2030. So we've got to march to that point, to the extent that you start thinking about things like all of the technologies that you mentioned, Lawrence, and David has mentioned as well. When you start getting that level of value put on carbon by a federal government, a lot of these technologies start to come into being economic without much support. That said, there's still, of course, some political uncertainty with certain things as government and leadership changes. But that CCUS technology, as far as I'm concerned, is available now. And maybe I'll if you don't mind, I'll just sort of stay on the soapbox here, Lawrence, and mention another type of technology that's maybe not as advanced as CCUS, and that's CCU, or the utilization of captured carbon. Capital Power has made an investment in an entity called C2CNT, which effectively stands for carbon to carbon nanotubes. And this entity, of which we own 40%, they've got a proprietary technology that converts captured carbon to carbon nanotubes. And carbon nanotubes are I'll call them a highly valuable material that can be added to a whole host of materials, such as building materials like cement, for example. And what these carbon nanotubes can do is, when added to materials like cement, they can increase things like tensile strength, decreasing the amount of cement, for example, that would need to be used in concrete. And because cement is a highly carbon intensive product to produce, the utilization of carbon nanotubes to reduce the amount of cement that needs to be produced has a downstream effect of being able to materially reduce carbon emissions as well. So that's I'd say that's the more novel type of technology that I was mentioning, that Capital Power has put some of its weight behind. In addition to our ownership in the C2CNT company and buy-in of that technology, we're also in a process of developing a commercial scale facility to capture carbon and then convert that carbon into those carbon nanotubes. Again, this is happening at the Genesee facility, but at Genesee 3. The idea there being, capture the carbon, put it through the proprietary process to create the carbon nanotubes, and then look to, of course, sell those materials to downstream users that would be interested in them for reduction of their own typical production purposes. It kind of speaks to exactly what Dave was mentioning, is the ability to reduce what we have or reduce what we're already producing. That's another way to drop the carbon footprint.
And go ahead, Dave, you were saying something?
I was going to say that's also great. I mean, if you think about how much energy and carbon intensity there is in concrete and other items like that, there's always the focus, and for this group it makes sense, on the utility side of the business, but there are so many other sectors in terms of transportation or building or just construction that are driving this, and what can we do to reduce that impact as well? It's something we can focus on.
Yeah, and I'm glad you brought up that point about cement, because obviously we have lots of infrastructure to be built around the world over the next 5, 10, 15 years. And all of those infrastructures will require a lot of materials. So I think it's important to see how you can decarbonize the sort of a construction sector, if you may, by using the energy sector as a catalyst. One technology we haven't talked about, and I'd like to get your thoughts on it, Dave, because I know you guys have a nuclear plant in Belgium, but any thoughts on small modular reactor? Where are we on that? Anything you're hearing? And maybe Jason can chime in too, because I know there's a big project going on in Canada. But you go first, Dave.
Yeah, there's definitely a lot of promising work. I actually really, really like the technology and think it is very valuable. I think where you have the hurdle with any nuclear technology is Fukushima and the aftermath of that, right? You have 3 Mile Island, Fukushima, you just have a host of Chernobyl, you have a host of issues, and you're seeing a lack of support for nuclear. You're already seeing Germany shutting down all their nuclear facilities. Belgium is starting to remove their nuclear facilities. France is really, and China are really the ones that are still championing nuclear. And it's really how no one's really solved, and France has probably done the best, but how do you solve the waste problem associated with nuclear energy? So I think the technology is great. I think it actually has a very strong presence in our future. I wonder and I question whether or not we have the political capital in order to move towards that direction. I just think there'll be too much public opposition towards increasing the share of nuclear energy in any market.
And I think on that point, though, I love to hear Jason. I think Dave, and I love this is getting a conversation going here, because I think that will depend on jurisdiction, right? I mean, if you go to the UAE, United Arab Emirates, they're pushing hard on nuclear. In Sweden and Norway and parts of Finland, they're pushing aggressively. And I think also what we're hearing now, if you're thinking, I think I read yesterday that the European Union is looking to considering nuclear as a part of the clean energy mix, which is a big deal. So I think you see some changing public sentiments with regards to nuclear. Even in the UK with the Hinkle Point, they're also looking at nuclear. But Jason, Canada, you got Ontario there with a very interesting project on small modular reactor. They're putting a lot of bets on that. What's your thoughts on nuclear?
Yeah, so I'll maybe speak just quickly to Capital Power's perspective, as that's outside, that's sort of outside and off strategy for us for the time being. But from my perspective, and as I think about things like Dave was mentioning, I think SMRs are they're an extremely interesting technology. I think that's other than some of the other things that we've mentioned, like for example renewables paired with long duration storage, or some of the hydrogen or CCUS type of measures. Long-term reliable baseload power seems to me like SMRs are a great way to facilitate that. Now, from a, I think as Dave was mentioning, from a regulatory, from a permitting, from a NIMBY, from all those perspectives, there's just so many headwinds for it. But it does have, the counterpoint is all those headwinds to a large extent can be battled back against by, like I mentioned, you've got reliable carbon-free power, a reliable carbon-free power source. The SMRs, I'm not too familiar with the technology, but I think if I rewind the clock back 5 or 10 years, you would have think of nukes as these monstrous capital investments that take 10, 15 years to develop, and they've got these 50 to 100-year lives, and it's really difficult for any entity. It's probably it's got to be a government or something of the sort, which might even be harder to wrap their heads around investing in. But with the SMRs, you sort of drop down that hurdle, and maybe there's an opportunity for them in the future. But I agree with Dave. It's just it seems like a real 50-50 right now as to whether or not you can get those off the ground, despite the fact that there's all of the benefits that come along with them. So from my perspective, interesting, certainly one to watch. But from Capital Power's perspective, obviously being a far smaller entity than ENGIE, it's a pretty long putt at this stage.
Yeah, I would agree. I mean, we have nuclear facilities. I just think it would be pretty hard to get past the history of nuclear, especially Jason mentioned the cost overruns. Hinkley has massive cost overruns. The Vogtle in Georgia has massive cost overruns. It's really going to be tough to take that and convince certain regulators to move forward. But Lawrence, I agree. I mean, the UAE, China, there'll be certain areas where it probably makes sense and you can get past those hurdles. but many of the markets that we operate in, I don't know that we'll get past those hurdles, and that you'll see private companies taking that first. I think it would have to take a government pushing forward with that first.
Well,
Well,
and maybe that's what we'll see, right? Maybe we'll see one of those countries or those governments take that first step, like any other private entity would have to take a first step and place a bit of an early mover advantage type of bet on a newer type of technology. That's not going to happen from the private sector. Maybe it happens from a country or from a government, and that's what sort of spurs on a technology. But yeah, certainly an interesting one to watch in that space.
Well, let me just tell the audience, if you have your questions, please send them in the chat box and I will try to incorporate them in the conversation. So perfect segue. We talked about, governments getting involved to try and make this work. Again, a week from now, the governments will be in Glasgow. Let's talk about the fact that the world has 7 billion people. And majority of them live in countries in Africa, Latin America, Asia. And they're going to need power. And in fact, many of them is still, for some time, rely on fossil fuel just because, that's what they have. And clean technology hasn't been scaled up in those countries. So how do we get these new technologies you guys are talking about? How do we make them available for the rest of the world?
Yeah, so I can try that first. I think there are several important things that are going on. I do think it's on the wealthier nations of the world, like the US, Canada, UK, France, to invest in these technologies to drive the cost down so it becomes much more attainable. And I think we also have to recognize that many of these other countries have not had access to power under any circumstances, reliable power grids under any circumstances. And so I think it's important that many corporations have already taken a step to say they're not going to finance fossil fuels in those areas. But we also have to make sure that then we do provide that, a good source of power that is reliable is provided to those countries. I think that it requires investment by governments, by private entities into transmission. I think you need to have that in the first world countries right now as well, because you need to be able to produce the power in one location and utilize it anywhere across your grid. And we're starting to see that. We have lots of transmission lines that we're building in Brazil and we built in South America. And that's allowing access to power that other people have not had before, just because that grid simply does not exist. It's not enough just to build a power plant or even smaller power plants and distribute them around. We have to be able to allow that grid build out to happen. And it's going to take investment from governments, investment from NGOs, investment from private corporations in order to allow that to happen. So I think it's important to export the technology that is distributed generation to those villages, but also to allow and to incentivize the build out of a transmission system, which again, we have to do here in the US, probably have to do it in Canada as well. I know there's controversial things about bringing Quebec Hydro down through Maine and into Massachusetts. Those are the things that we need to do in order to allow access to good, clean, reliable, renewable energy, because it can't just be produced anywhere. And the same holds true for coal, the same holds true for natural gas. You have to transport it to a location to generate it and then distribute that power. Let's utilize what that natural resource is in that area and then build out a distribution and transmission grid to allow that to be utilized.
Jason, let me take Dave's response and frame a question for you. And so one of the things that Dave alluded to was this idea that, the developing countries are being told now that they cannot use fossil fuels, and they're not going to be investing in fossil fuel from the developed countries. You have, the EU and other governments saying they're not going to do it. So how does a government that has, like say India with 400 million people lacking access to electricity, but they're sitting on a lot of coal, how does one convince them to not use coal? And if they're going to use it anyway, isn't that where CCUS comes into play? Because at the end of the day, they can't have 400 million people without access to electricity waiting for wind and solar if it's not scalable. So do you see a potential use of CCUS in those countries?
Yeah, I think so. And I want to go back to something that Dave mentioned. It reminded me of something. I can't remember. I was sort of either reading or listening to something over the course of the weekend. But this concept of in the developed countries that we're advancing the technologies, and those technologies can then be deployed in the less developed countries. It almost reminds me of sort of, I don't know, like the monitor I'm looking at, right? It's like I got a nice 22-inch monitor. It's really flat, and it probably, the first time this thing was produced, it probably cost $5,000-10,000, and somebody had to produce that and somebody had to buy it. But now you can get them for $300 or $400 at Best Buy, and away you go. And I think that's that sort of like this almost like this trickle down effect of technology, and it applies to the electricity sector as well. So I'm not totally answering your question on how we can convince India not to use its coal, but if there are technologies that can help make thermal, maybe not necessarily coal, but can make thermal cleaner, then hopefully we can get ourselves to a point in more developed places that have more advanced infrastructure and have cleaner electricity sectors to be able to trickle down and deploy that technology in other places. Because I would agree with Dave as well. I think this is a point that he made. You can't have people without electricity, and I think it's you don't want to be running a marathon before you figure out how to walk, and saying this is exactly the type of technology that you have to deploy. You need the technology, you need the infrastructure, and so on and so forth to get everybody electricity before you start saying this is exactly how you have to do it.
I think also too, it's inherent upon large companies like ENGIE. We operate in India. We're investing in those communities and providing jobs, and reinvesting in those communities. And I think that's how you do it, is you show the promise of reinvestment in those communities, the clean energy, and moving away from those fossil fuels. I recognize that takes away jobs from people that are mining that coal, but there are you can create other jobs with inside the renewable energy industry on top of that. And even just providing access, energy provides a major thing to many communities that they just don't have now, which is clean water. And having clean water is also a huge lift in all of these communities as well. So we need to reinvest in these communities when we're moving in there, and I think that'll help transition.
Yeah, and I think going to Glasgow, and I really like this the direction this conversation is going, because now it's bringing us to, I think, what's going to be the crux in Glasgow, which is the need for partnerships and collaboration, both with the developed and the developing countries, but also in the private sector, where you will start seeing collaboration between companies. So talk a little bit about partnerships. You mentioned, Jason, that you all have invested in the company that is doing the nanotubes research. Can you start first and just highlight some of the strategic partnerships Capital Power have put in place as it relates to this, and then we'll go to Dave. But you go first. Talk about partnerships, both for government and private sector.
Okay, so maybe I'll go away from the carbon nanotubes for a second and just jump back onto what Alberta, the province of Alberta, is doing with the sequestration tenure rights. So not necessarily a traditional type of partnership, but you've got the Alberta government that's going to look to a competitive process to, as I mentioned, allocate those sequestration rights. Those sequestration rights may go to infrastructure companies or companies that have more traditional hydrocarbon drilling type of expertise. Then there's also going to need to be a transportation partner as well. It may be the same as the sequesterer, but there's going to be a transportation leg as well. You've got to move that carbon from the source of emission to the source of sequestration, and then you've got the emitter and the capture. So an example might be with the Genesee facility. Capital Power may be interested in taking on the investment and the operation of the post-combustion capture unit, but maybe not necessarily the transportation infrastructure to move from emitter or move from emission source down to where the carbon is going to be sequestered. So that might bring in another partner that's got the transportation infrastructure investment, and then a third partner who may be the sequesterer, and then they're responsible for the MMV, et cetera, et cetera. So you've got an emitter / capture, you've got a transporter, you've got a sequesterer, all linked up together with the Alberta government, who's got to hand out those sequestration rights. So, just maybe I speak more to examples than more broadly, but that's sort of something that's quite recent and relevant to Capital Power when we think about partnerships and the partnerships that we need to form to decarbonize our fleet.
And Jason, Dave, you guys are multinational, so you're in many different countries. So your partnership must be very complicated in terms of the different parts of the world. Can you talk a little bit about some of the partnerships that you've worked on that have sort of a born success?
Yeah, and obviously I'll be most familiar with the U.S. side of it because that's where I'm based. And you're right, we have partnerships across the world with both governments and private entities that are helping towards the carbon neutrality. One of my counterparts, Stefan Sirk, who runs the energy solutions business here in North America, And one of our more successful partnerships actually is with Ohio State University. We're going to operate their facilities for the next 50 years. And the only way we get paid is actually by driving efficiency into their operations and really energy efficiency. They need to see savings. And so we're in a lot of those public-private partnerships where we're operating their district heating and cooling and reducing their carbon footprint and their actual energy usage across their entire campus. So we've got multiple universities, we work with large corporations in that regards. And I think those are very, very important to drive an efficiency into some of these universities and others. That's not their primary goal. The primary goal is obviously to educate the next generation of leaders. And so we are there working towards reducing their carbon footprint and their overall energy usage. And that's how we are extracting our value out of that as well. So it's I think those types of partnerships are key to driving this in the future, bringing the experts who can handle that, let them focus on their core business.
Yeah, and I imagine there's going to be more of that announced next week in Glasgow. We already heard the announcement between Microsoft, Bill Gates, and the Breakthrough Foundation and British government. We have a question from the audience from Vivian Bashal, and the question is, the continent of Africa is exporting a lot of minerals to enable clean energy in the developed world. How can you help Africa to process its own enablers for clean energy? There is a multiplier effect that is being lost when these minerals are taken out of Africa without processing them. So I know this is not specifically something you guys may want to opine on from your company's perspective, or do you may, but just broadly, I mean, we're having this very global conversation. What are your thoughts on Vivian's question?
Yeah, like you mentioned, Lawrence, it's probably not something that from a Capital Power perspective that I can necessarily comment on, or something that we'd be involved and engaged in. But I think it's a really good question, and it may come down to the entities that are responsible for the manufacturing of these clean technologies, that they look to go straight to source. So rather than transport the raw goods, whether it's across continents or countries or what have you, seek opportunities to avoid that transportation cost. See if you can manufacture in those areas, and then ideally avoid the transportation costs altogether, and you can deploy in those countries. So I think it was referred to as a multiplier effect. Yeah, I agree. There's probably some opportunity there, but I can't necessarily speak to what some of the barriers are to doing what I mentioned. That seems logical, but I mean, it's easy for me to say, not necessarily being in that manufacturing space.
Dave, you have any comments on that?
Yeah, so from the ENGIE perspective, I mean, this touches on some other items that we're working on in regards to forced labor, and you see a lot of issues with how they're extracting minerals in these locations, and leaving a population that's not being paid very well, and environmental damage behind that. So we as an industry, there's SIA has pledged to drive out any forced labor. We're not aware of it being utilized in ours, but we want to make sure that we eliminate that. And I think part of that is increasing the investment in these countries and providing the benefits to those employees to make sure that they are taken care of, whether or not it's processed there, but to provide the real value associated with those materials. And it's obviously a very geopolitical hot button item that ENGIE or myself personally can't always touch on, and how you would handle that. So I will artfully dodge it that way.
No, well, it's an interesting question, and I should say that on Wednesday we're going to be having a panel session, another session here, which will focus on the supply chain. And so Vivian and others, if you want to listen in on that session dealing with the supply chain, I'm sure we're going to get into some of these issues, because that's where critical minerals become very critical from the standpoint of renewable energy. We have about 7 more minutes left. Let's just wrap up with two questions here. We've talked about some of the issues around the partnerships, but just quickly, are there risks or barriers you see towards making these technologies scalable and completing the sort of the research and development that's important? Any thoughts on the issue of risk or barriers we need to overcome? Go first, Jason, and then Dave.
Yeah. So sorry if I sound like a broken record, and I keep bringing to the forefront CCUS, but I think when it comes to de-risking and pardon me, and moving some of these technologies forward, I think with respect to renewables, solar, wind, I mean, I think that's pretty boilerplate, right? Like de-risking can be done through offtakes, et cetera. But when it comes to CCUS, and I think this applies to a lot of other technologies as well, is I mean, a big risk often sits in a regulatory and a policy environment. I mentioned Canada's march to $170 per ton by 2030. I have no reason to doubt that Canada is not going to get there, but a headline price of $170 per ton doesn't necessarily translate into a market price of $170 per ton offset. So there's a market that underlies a headline price that is also developed by regulatory and policy principles, and some de-risking around the value of that revenue stream from post-combustion capture would absolutely go, like it would go an extremely long way in allowing investments in these technologies, especially at this early stage, to get off the ground.
Dave?
Yeah, so I agree with Jason, and I think to build on, four major risks I see is, which is really the non-existent carbon pricing. You don't really have that in the US, you have it in the EU, you have it coming in Canada, but and really this is something I'd like to see come out of COP26, is more of alignment on that. I think it's going to be very difficult to do so on a political level, at least here in the US, but really a non-existent or an inconsistent carbon price across there. And then you have really unstable policy and tax environments across the globe. You have Spain reversing, because of the high natural gas, they're reversing auctions that they've already had in terms of renewables to take that back. You see that in other countries. You see it really slightly in Canada with the elections. There was a thought that may change. You have it in the US with change of parties. You're just seeing an unstable tax and regulatory policy across the world. That includes trade wars, particularly between China and the US. And I do think that really impacts solar and impacts wind here in the US. And then, the pace of the market environment to reflect these changes, how you're operating the grid, how you're handling what are more intermittent resources today, and how you really handle that as you're reducing your coal footprint and you're increasing your renewables penetration. How do you really handle that grid market evolution? And I think one of the major risks that you see in most of all countries as well, and hopefully we can solve that in less mature countries, is the grid access. It's incredibly slow, incredibly difficult to get onto the grid. The grid was not meant for hundreds of generators spread throughout the countries. It was really meant for some very small, large generators that are in non-load centers transmitting a good distance. But we really have to upgrade our transmission system in order to get the power from where it's produced. And, particularly in Midwest US and, Central Canada, there's not a lot of load, but there's a lot of ability to generate. And the loads are all on the coast, where maybe there's not as ability to generate as you see. And so how do we solve issues by being able to efficiently transmit electricity the same way we transmit natural gas right now in hydrocarbons? We're very good about moving that from where it's produced to where it's used. Let's do the same thing with renewables.
So I think we need to take a holistic approach to the infrastructure that's necessary for achieving the energy transition, but also meeting these carbon goals. I think that's a very important point. A lot of other technologies we didn't talk about, obviously, artificial intelligence, fusion, marine energy. But I'd like to end on your reflection on one interesting question. I would like to get perspectives from folks like yourself. So we're going to go to Glasgow, and people will come from there with all kinds of expectations in terms of what is success. And we will remember what happened in Copenhagen. We also saw what happened in Paris in terms of success and no success. So 2 questions in one for both of you. Let's start with Jason. So what excites you the most about the future of energy technologies as you see it? And based on that, and based on your perspectives, both from Capital Power, but also as a citizen of the world, what would you consider as success after COP26?
Okay, so starting with the first, this is an easy one. So what excites me most about the future of energy technology? So we're doing it right now. Like, the future is now. I mentioned our investment and deployment of the C2CNT technology. I mentioned our exploration now for fairly recent deployment of CCUS. That's what excites me most. Is this is not a 5, 10, 15, 20 years into the future, this technology might be viable. These are things that we in Capital Power are working on today, and that's what's so exciting. It gets me sort of out of bed in the morning, if I can use the cliche. Consider a success at COP26. It's no secret that this is a really tough challenge, is to advance all of the countries towards decarbonization. I know that there are, like Capital Power and ENGIE, some longer term goals and commitments and roadmaps that have been developed to get there. There's also some real short-term things that are being done. What I'd like to see, and I think what would make a success, is we're never going to lay out a roadmap for the globe for the next 30 years. But what we can do is we can take some incremental steps every time that there's the I'll call it the global meeting to advance the incremental steps that all the countries can agree to and need to take. So I think it's more of a baby steps type of approach, combined with those longer term goals, as opposed to, I'll call it the more sort of I don't want to call it fluffy, but sort of the more aspirational and qualitative. Getting some of those quantitative in there too, even if they're just small steps that can be incremented on annually. I think those could be those could really drive towards a success this year.
Good. Dave, excitement and also your key KPI for success coming out of Glasgow.
Yeah, so excitement. I actually think agree with Jason in terms of it's here, but also really what's exciting is it's not it's really that corporations and the populace are behind this change. Even if there are forces in governments and others that aren't necessarily behind this change, the people and the corporations are really driving this. You saw in the last 4 or 5 years, large U.S. corporations, international corporations, driving global climate change initiatives across the globe and buying renewable energy and driving that forward. And that's really what the general population is looking forward to. So I think that's a great transition forward for the renewable energy industry and the electric industry itself. And then really for COP26, obviously seeing a repair of what, kind of the step back that happened in the US, but also really seeing a greater alignment, see if we can get to a move towards a more global standard, just like we did on taxation, corporate taxation. Can we get a global standard on carbon pricing, which will help enable it across the board?
Well, listen, this has been a very fascinating conversation. We didn't have enough time to cover everything. We sadly got a last comment in from Richard Fennelly, and I will bring it up to wrap things up. And I normally don't like to do this, but just because I think he raises a very interesting point. And he raises the point around, and I'll read what he writes here. There's way too much focus on deploying new things to fight climate change and not enough in maintaining in tip-top shape what is already deployed. Lack of maintenance in the cooling industry, for example, causes 500 billion metric tons each year in unneeded power plant emissions through energy inefficiency. I think that's a very interesting point. Maintenance of what we're going to build is going to be just as important. And I know that ENGIE is already playing in this space by maintaining assets around the world, and I'm sure Capital Power. So I think let's end on this note that we need to maintain what we build as well as make sure that the efficiency we gain from the new things are maintained over time. So Dave and Jason, thank you guys so much. It's been a very, very interesting conversation. I know you were both wondering how we're going to get through the hour, just the three of us, but like I said, we did it, and we did it with a lot of excitement and a lot of good feedback. So thank you guys for doing this. Let me turn it over to Vanessa to close things up. Vanessa.
Thank you so much to Dave and Jason for joining us today and sharing their insights with us. And thank you to everyone for joining the conversation and asking so many thoughtful questions throughout the session. We will be sending out a recording to all attendees, which we'll also be sharing on our YouTube channel, where you can find recordings from other past virtual conversations and webinars. We encourage you to register for other sessions in this webinar series by visiting tinyurl.com/EEI-COP26. Our Destination 2050 dialogues will continue this week with sessions focusing on climate resilience, supply chain risk, and how to become nature-inspired leaders and communicators as we address the challenge of climate change. To continue engaging with EEI international programs, please follow us on Twitter or visit our website. Thank you so much and have a wonderful rest of your day.